Now we'll discuss null hypothesis. Null hypothesis is an assumption that is used in stats. In stats, we consider there is no significant difference between two populations. So we'll discuss this session according to following learning objectives. First, we'll define what is null hypothesis. Then what error arises from null hypothesis. Then what is p-value or probability value. In the end, we will summarize the session. So let's start with the definition. Like, simply remember one thing. Null hypothesis states that no difference. There is no difference between two populations. Or we can say there is no difference between two proportions. If different arises, it may be due to some error. Which error? It may be due to some sampling error, or it can be purely by chance. So remember, statement of null hypothesis. Null says no difference. It is denoted by H naught. What is M? It is applied on test of significance. It is applied on chi-square test. It is applied on Z test. It is applied on T test. Formula of null hypothesis is commonly asked. It is H naught 1 is equal to 2. This is the formula of null hypothesis, that there is no difference. Sometimes error may arise in null hypothesis. There are two types of errors, alpha error or beta error. So they are not only sampling error, there are calculation errors also. Like, what is alpha error? Alpha error, we can say that we wrongly reject null hypothesis, or null hypothesis is rejected falsely. Is rejected but falsely. This is alpha error. What is beta error? Null hypothesis is wrongly accepted. It was wrong, but we wrongly accepted it. Remember, we have to accept or we have to reject null hypothesis. So we will accept that null hypothesis is true, or we reject that null hypothesis is false. But how we accept or how we reject null hypothesis? On the basis of p-value. What is p-value? Value of probability. Remember, standard set for p-value is 0.05. 0.05 is standard p-value. It is according to 95% class interval. What 0.05 indicates? If p-value is 0.05 or greater than 0.05, null hypothesis is accepted. Why? But it is probability of acceptance. P-value increases, probability of acceptance increases. If p-value is less than 0.05, then null hypothesis is rejected. Remember these two values. Remember, p-value 0.05 is standard value. If it becomes greater than 0.05 or 0.05, it is accepted. If it is less, it is rejected. Let's solve a scenario. In a given scenario, p-value 0.07 and 0.03. 0.07, we accept the null hypothesis. For 0.03, we reject the null hypothesis. We have to accept it or reject it. We have discussed null hypothesis. What is null hypothesis? It's an assumption. Instead, we use null hypothesis for various tests of significance, like chi-square test, t-test, z-test. Null hypothesis states that there is no difference between two values. There is no difference between two populations. There is no difference between two proportions. They are same. And there is no significant. Remember the word significant. Because 5% difference is acceptable instead. There is no significant difference. So remember this. Definition of null hypothesis. We apply null and application. Null hypothesis applied in tests of significance. Then there are errors may arise in null hypothesis. There can be alpha error or there can be beta error. What is alpha error? Null hypothesis is true, but we reject it. We falsely reject it. P-value should be 0.05 or greater than 0.05, but while calculating p-value, there may be calculation error. We falsely reject null hypothesis. It was true. That is alpha error. What is beta error? Null hypothesis was wrong. P-value was less than 0.05, but we accept it. While calculating p-value, we may make a mistake. We can make a mistake. This is calculation error. So remember alpha error and beta error. Then we discussed, oh, we accept or reject null hypothesis. Definitely on basis of probability. Remember, total probability is 1. Total probability is 1. And in stats, we take standard p-value 0.05. So probability is 1 and 0.05 is standard value. If p-value is 0.05 or greater than 0.05, null hypothesis is accepted because it's the acceptability or probability of acceptance of null hypothesis. If p-value is less than 0.05, it is rejected. It's a common university question. You can be given two values like, let's suppose you are given a set of p-values, p-value 0.05, 0.09, 0.02, 0.03. What is your interpretation? For 0.05, we can say that null hypothesis is accepted. For 0.09, we will accept null hypothesis. For 0.02, it is rejected. For 0.03, it is rejected. So you should simply remember these values. You should simply remember 0.05. What happens if we reject null hypothesis? Let's suppose if we reject null hypothesis, what will happen? There is another hypothesis, alternative hypothesis. Null hypothesis is rejected and then we have to accept alternative hypothesis. What it states? It states there is difference between two values. 1 and 2 populations are not equal. This is formula of alternate hypothesis. So either we have to accept or we have to reject null hypothesis. If we accept, like in a trial of vaccines, let's suppose there is a trial of vaccines. There are two vaccines available for coronavirus. One is Sinopharm, one is Pfizer. Companies do claim that their vaccine is superior. One company claims their vaccine is superior, other claims their vaccine is superior. And they give the data. Sinopharm gives that after injection of Sinopharm, only 10% of population is infected with coronavirus. And Pfizer say that after injection of Pfizer, only 5% of population is infected. Apparently, Pfizer is superior. But we have to apply certain tests. We have to apply null hypothesis to see that whether this difference is statistically significant or not. Because they have not given the data regarding population. If Sinopharm vaccine is applied to immunocompromised, they may get reinfection. So we don't have any data regarding population. We have to apply null hypothesis. We see the p-value. We see the significance of difference. If it is greater than 0.05, we say that there is no difference between Pfizer and Sinopharm. But if it is less than 0.05, we will say there is difference between Pfizer and Sinopharm and one vaccine is superior. So we have to classify according to null hypothesis. Null hypothesis gives us an indication whether difference exists or it might not exist. Then if we reject null hypothesis, we have to accept alternate hypothesis. That's all.